everybody, Dr. Nelson here. This is a video lesson about corresponding parts and scale factors. All right. So to get you started, I want you to kind of consider these two terms as like tools that you'd use in a toolbox. Okay. So corresponding parts and scale factors are certainly tools that you're going to use later on to solve more advanced problems. All right. So before we talk about that though, all right, let's review real quick scaled copies, okay? So remember, a scaled copy is a copy of a picture that changes size, right, but does not change in shape, okay? So there's a key thing about this. So remember, it changes size, right, but the shape does not change. So what I did is I took this little arrow here, okay, and I made a copy of it, and then I made it larger. So this larger arrow has the exact same shape as the smaller arrow, okay, but it has different size, right? So that's what a scaled copy is. All right, now there's a really important term called corresponding parts, okay? When part of an original figure matches up with part of a copy, we call them corresponding parts, okay? And this could include obviously points, segments, angles, or distances, all right? So let me kind of give you an example, all right? So here we have a triangle called ABC, and here we have another triangle called DE and F. And notice DEF is a larger version, okay, of ABC, right? So DEF is a copy of ABC. But there's three corresponding parts. All right, let me use a different color here. Let me go with green. All right, so notice here is point A, okay, and point D corresponds with point A. All right, this is in the top left-hand corner, right? And point D is in the top left-hand corner. All right. Another example would be, let me use red, okay? Point B would correspond with point E. All right, so E matches up with point B. And then there's one more. All right, you probably see this already. Point C corresponds with point F. All right. So point A corresponds with D, point B corresponds with E, and point C corresponds with F. So again, these are called corresponding points, okay? Now, here we have the same two triangles, but now we're going to talk about corresponding angles, all right? So first of all, focus on angle A here. Again, let me use a blue color, okay? And angle A, right, would correspond with angle D. Okay, angle A and angle D are the exact same angle measure. So if angle A is 50 degrees, angle D would also be 50 degrees. Angle B corresponds with angle E. All right, so again, they have the same angle measure. And then finally, angle C would correspond with angle F. All right. So angle A corresponds to angle D, angle B corresponds with angle E, and angle C corresponds with angle F. All right, now corresponding sides and angles, okay, as well as points, are used to come up with something called scale factor. All right, so to create a scaled copy, we multiply all the lengths, okay, in the original figure by the same number. Okay, this number is called the scale factor. All right, so notice we have a small right triangle, and we have a copy of it, which is a larger right triangle. And notice how it's color coordinated. So this 2 corresponds with this 4. This green 2 corresponds with the green 4. And then finally, this black 3.5, the hypotenuse, right, corresponds with this black 7. Now, let's first focus on the blue, okay? So to go from this side to this side, to go from 2 to 4, we have to multiply 2 times 2 to get 4, right? Now, to go from this 2 to this 4, we can multiply this 2 by 2. And then finally, to get 3.5 to 7, we'd multiply 3.5 times 2, right? So the scale factor for this problem is going to be 2. But let me show you another way of doing that. What you can do is you can take, okay, a side length of the copy. So let's say it's let's go with this 4 right here. Let's take that 4, and you can divide it by the corresponding side length of the original. which is 2. And when you do 4 divided by 2, you get 2. All right, let's do the same thing, but let's do the green sides this time, okay? So I'm going to take this side right here, which is 4, and divide it by the corresponding side to that side, which is this 2. And 4 divided by 2 gives you 2, and that's called the scale factor. Here's another scale factor problem, but this time notice our original shape, this original rectangle, okay, is larger than our copy, right? So it's actually decreasing in size, okay? So to determine the scale factor, you may also divide a side length, okay, of the copy by the side length of the corresponding side of the original, okay? So I'm going to go with, say, this side here, okay? So we're doing 3, okay? And I know this 6 corresponds with the 3. All right. So when I do 3 divided by 6, all right, so I'm going to put the 6 out here, 3 in here. I get 5/10, right? Now 5/10 is 1/2, so the scale factor for this problem would be 1/2. All right, so let's try this one together. So it says determine the scale factor from the original shape to each copy. All right, so we have 3 problems in one. So here is our original shape, okay? And here's our 3 copies, copy 1, copy 2, and copy number 3, okay? So again, what you have to do is locate the corresponding sides, okay? So I'm going to match up, let's say, this side. All right, with this side, okay? And when I do 8 divided by 4, I get a scale factor of 2. All right, let me erase that real quick. All right, now let's do the second one, okay? For the second one, I'll use blue. Now this time, I'm going to use blue to highlight the corresponding side. So here we have 2, and here we have 4. All right, and notice that the original shape is larger than the copy for number 2. Okay, so when I do 2 divided by 4, that's 1/2, right? So the scale factor would be 1/2. And then finally for the third one, all right, I'm going to correspond the 3 with the 4. All right. And when I do 3 divided by 4, okay, that can be written as 3/4. So the scale factor for the first copy was 2. The scale factor for the second copy was 1/2. And the scale factor for the third copy was 3/4. All right, so now let's try this one last problem together here. All right, so this is a real life application. So it says a car dealership named Tarbox, okay, wants a copy of their business card logo to be displayed on the following billboard. All right, so again, they want this little card here, okay, displayed on here. So we need to make a scale copy. All right, so it says the dimensions, okay, of the Tarbox business card is 2 inches wide. Okay, so 2 inches wide and 3 inches, okay, long. The billboard, the width of the billboard is 20 feet. Determine the scale factor used to determine the billboard. All right, so this one's a little bit tricky, but so we know that the width of the billboard is 20 feet, right? So I'm going to write 20 feet right here. But here's the thing. Notice here we have inches, and over here we have feet, all right? So what we have to do is we have to convert the feet to inches. Okay, so I know that there's 12 inches in a foot. So if I do 20 times 12, I get 240. Okay, so I'm going to cross this off and write 240 inches. All right. So now what I can do is I can now figure out the scale factor by comparing the corresponding sides. Okay. So here we have 240, and here we have 2. All right. So when I do 240 divided by 2, I get 120. So the scale factor for this problem is 120.